Now, today we are learning or we are studying some of the examples of brute force techniques. First example is selection sort technique. First, we are animating the how actually the selection sort work. Then I will explain how the algorithm is actually written for the selection sort and explain how actually the selection sort works. In the selection sort, we consider the array as the list as the unsorted order first, and we are scanning the entire given unsorted list to find its smallest element and exchange it with the first element, putting the smallest element in its final position in the sorted list. What is the meaning here is, if you consider this one as the unsorted list, we are scanning all the elements here from the first element to the last element. We are checking which element is very smaller one, and we are picking that smaller element and exchange it with the first element. In the second pass, we are already the first element is in sorted order, so we are starting from the second element to the last element and scan the second largest element, scan the smallest element within this group, and we found that this one, and exchange with the second element. Like that this process continues. This is called as selection sort. How actually the selection sort works? Now see, scanning the entire given list to find its smallest element and exchange it with the first element, putting the smallest element in its final position in the sorted list. Then once the pass 1 is completed, then we scan the list from the remaining unsorted list, that is starting with the second element, and find the smallest among the last n-1 elements and exchange it with the second element, putting the second smallest element in its final position. In the ith pass, whenever you repeated the process, in the ith pass, the state of the elements will be look like this way. Now we have to, these are already in the sorted, these are already in the order or sorted elements. Now I have to sort these number of elements from the ith element to the n minus 1 element. I want to search for the minimum value here. Whenever the minimum value found, you just exchange with the ith element. This process continues up to 0 to n minus 2 passes. After n minus 1 pass, the list is sorted. Now see this algorithm. In selection sort algorithm, it will accept one array as the element with n number of elements. Once the sorting is done, the output will be sorted or non-decreasing order. Now how this algorithm works? This is the logic for the sorted array. We are starting, I is actually starting from the 0 up to n minus 2. That is last but 1 elements. And initially we consider the first element as the minimum element. If you see here, the I is initially pointing here. I will consider this one as the minimum element. The I is actually positioned here, and this is the minimum element. Now we have to scan the remaining n minus n elements here. Okay, we have to scan the remaining and check which is the smallest one. And the smallest element is actually stored in the minimum. Okay, now this is the concept we applied here. Now this is the array to sort using selection sort. Now we consider this one is the first element here, and it is nothing but pointed by I. The I will be moved from the first element up to the n minus 2 element, up to here. And we have one more variable called as minimum variable, and this minimum variable is initially pointing to the first element, and this minimum variable contains the smallest element in the list. Once the pass is completed, this minimum variable contains the smallest element of the list, that is its index value. Okay, now we have one more variable called as j, and this j variable starts from the second element to the last element. We are comparing all the elements which is pointed by j with this minimum element. If this minimum element is larger than the j, then we just exchange that element with the minimum element. For example, see, initially the minimum element is 89 here, and j is actually pointing to the 49. So the minimum actually contains actually contains 89. Now this 45 is compared with the minimum here. This is compared with 89. It is smaller. 89 is smaller. So this 89 is replaced with 45. Okay. Now it is go to the next line here. J is pointing here. Okay. 68 is larger than 45. There is no any swapping. And it is compared with the 90. 90 is again larger than the 45. There is no any swapping. Then 29. 29 is smaller than 45. So the minimum is replaced with 29. Now again it is compared with the 34. J value is pointing here. 34 is actually compared with 29. 29 is smaller, no exchange. Then it is compared with the 17. 17 is the smallest element, so it will store the 17 in the minimum. In the first pass, we found that 17 is the smallest element. Actually, it is pointing the index value of this one. Here 0, 1, 2, 3, 4, 5, 6. The index value of this one is 6. So the minimum contains the index value of 6 here. Here 6 is nothing but it is pointing to this element. Now we have to exchange this 17 with the 89. The swapping will be done. 17 will be swapped with the 89. 17 comes here, 89 comes here. This is called as the pass 1. Okay, in the pass 2, we are starting from the second element here up to here. We are scanning which one is the smallest element. We are just exchange with this element. Okay, the process continues until n minus 2 passes. We have to come from here to here, where comparison will be done here. Okay, this is called a selection sort. That is explained here. Okay, initially we are having I value 0 up to n minus 2 iterations. Initially the first element is the minimum element. We are scanning from the second element to the last element. We are scanning from the second element to the last element. If that A minimum is larger than the element in the array, we just exchange with the minimum is exchange with the element array. Now once all the pass will be completed, we found that the minimum contains the smallest element in the unsorted list. Minimum contains the smallest element in the unsorted list, so you just swap it. The minimum is exchanged with that minimum AR. That is first element. Okay, that is called as selection sort. Now we will study that concept here. In the first pass, we found that scan that entire list. In the entire list, we found that the 17 is the smallest one, and you just swap it with the first element. Okay, here we done the swapping here, and these are the elements which is not in the order. In the second pass, we consider from the second element to the last element and do the scanning again. We found that the 29 is the smallest element in this list. So we just exchange this 29 with the 49. Now 29 comes here. These two elements are already in the sorted order. Now I have to start from the third element, that is 68, up to 89 here. And we found that the 34 is the smallest element. We have to exchange with the third element. Once we exchange it, 34 comes here, 68 comes here. Now see here, 68 comes here, 34 comes here. Now this is in the sorted order again. Now we have to sort from here to here. And we found that 45 is the smallest, so we have to swap these two numbers. Once you swap, 90 comes here, 45 comes here. Now this is the sorted value. Now start from here to here. 90 is replaced with 68. 68 comes here. 90, 89 comes here. Now 90 and 89 is compared. N minus 2 and n minus 1 we are compared here. Found that 89 is smaller. Just exchange. And 90 is placed here. And this is called as selection sort.